Okay, this is still day 16. We're going to do the other side. I'll show you really fast. Day 16. Okay, so we're going to start with number 1, and it says, cross out the bug that has 3 prime numbers on its stomach. Okay, so remember what we talked about prime numbers, guys. Hopefully you memorized the first 5 or 6, but let's just look at this bug. And we know that a prime number has only 2 factors, 1 and itself. Okay, composite numbers have more than 2, but prime numbers only have 2. So if you look at this bug right here, and this is a number 15, it ends in a what? It ends in a 5. Well, every number in the whole world that ends in a 5 has 5 as a factor. Because if we're counting by 5s, 5, 10, 15, 20, 25, all of those numbers are going to end in 5 or 0. So we already know that this is not prime. Okay, so we can look at number 27 and remember our 3 divisibility rule. You can add these digits together. So if we have 27, 2 plus 7 is 9. Well, if the sum of these 2 digits equals a number that 3 is a factor of, then you know 3 also goes into this number. Okay, if you sing your 3 song, 3, 6, 9, 12, 15, 18, 21, 24, and 27, you're also going to know that that's a composite number. Now, 7 is a prime number. Okay, so it did have 1, but that's not what it says. It says that has all 3 prime numbers, okay? Has 3 prime numbers. Okay, so we're looking at number 11. Okay, there's nothing that multiplied together besides 11 times 1 that gives us an 11, so we know that that's prime. We've got 31. Okay, so let's factor it really quickly. So we've got our T-chart. We always add our digits first, so 3 plus 1 is 4. We ask ourselves, okay, does 3 go into 4? Is 3 a factor of 4? Well, 3 is obviously not a factor of 4, so we know 3 is not going to be in our T-chart. We always start with 1 times 31. We know 31 is odd, so it's not going to have 2, 4, 6, 8, or any even factors. So the only thing we have to check, we already checked 3, we have to check 5 and 7. Because if 3 doesn't go in, 9 doesn't go in. So it has to end in 5 or 0 to 5 for 5 to go in. It doesn't. Okay, it ends in a 1. And then for 7, we'll just sing our 7 song. 7, 14, 21, 28, and 35. Well, we just skipped 31, so we know 31 is prime. Okay, so now we're going to check 51. So again, we do our T-chart. Well, our 3 rule is you just add the 2 digits, so 5 plus 1 is 6. Well, does 3 go into 6? Is 3 a factor of 6? Yes, it is. 3, 6. So as soon as we see that 6, guys, we know this is not going to be prime because we already know 3 is going to be a factor. So we can cross that off, and we know that that's not going to be the answer. So here we have 2, 13, and 97. Well, we know 2 is our only even prime number, so that's prime. We've got 13. You guys know 13 is prime. There's nothing that multiplied together except for 1 times 13 equals 13. So let's check 97 just to be sure. Okay, so I'm going to write 97. Again, the first thing we do is we add these together. The sum of these digits is 16. Okay, 3, 6, 9, 12, 15, 18. 3 does not go into 16. So we know it's odd, so all the even numbers are out. 2, 4, 6, 8, they're all out. So the only thing we have to check, since we already checked 3, is 5 and 7. Well, we know 5 does not go into 97 because it ends in a 7 and not a 5. So let's go ahead and divide this by 7 just to make sure. 7 goes into 9 one time. We put our 7. We subtract our 2. We bring down our 7. Does 7 go into 27? 7, 14, 21, 28, and 35. It does not go into 27 evenly, okay? So we know that 97 is also going to be prime. We only have to check numbers 1 through 12 to see if a number is prime or not. Okay, so we know this is going to be our answer that we cross out. Okay, it says use the rule y equals 3x to complete this table. So guys, if our formula is y equals, we have our coefficient and we have our variable, we do not have a sign in between our coefficient and variable, so we know that means multiply. So if this is y, okay, we don't know what y is, so I'm going to put a y. We know that it's 3 times x. Well, our coefficient isn't going to change, and our x is a 1. So y equals 3 times 1, which is what? Which is 3. So we know that our y is going to be a 3. Okay, our next one, we have our y is 9. So our formula doesn't change. Y equals 3x. It gave us our y this time, so I'm going to put 9 in for y. Our coefficient doesn't change. So what's our variable? Well, 9 equals 3 times what? What is multiplied by 3 to give you 9? 3, 6, 9. So that's going to be 3. So 9 equals 3 times 3. So that means our x is going to be 3. Okay, this time it gave us our x again. So we know that our rule up here is times 3. Okay, well, what's 6 times 3? 6, 12, 18. It's 18. Okay, again, this time it gave us our y. So let's just do the formula just because we can. So it gave us our y, so we're going to put 24 equals 3 times x. Well, what multiplied by 3 gives us 24? Well, let's sing our 3 song. 3, 6, 9, 12, 15, 18, 21, 24. So that's going to be 8. So 24 equals 3 times 8. So that means our x is 8. Well, this time it gave us our x again, which makes it easier because we already know that this is x times 3. So what's 11 times 3? It's 33. Okay. All right. So number 3 says Philip drew a floor plan of his bedroom for a math project. What is the area? So guys, if we know we are finding area, we know that area equals length times width. Okay. So we see, did they give us a length and width? Actually, they did. Okay. They gave us 13 and 12. If we were finding the perimeter, we'd have to put a 13 here and a 12 here. But our formula for area is just length times width. So all we have to do is plug in our numbers. Area equals length, 13. Our width is 12. And so what are we going to do with those two numbers? We're going to multiply them, okay? So we have 13 times 12. 2 times 3 is 6. 2 times 1 is 2. We've used our 2. 1 times 3 is 3. 1 times 1 is 1. We're going to add these together, and we end up with 156. So area equals 156. We look to see what our unit of measure is. Y'all, that's really important. They're going to measure in something, and this time it was feet. We did just find area, so that means our answer is going to be squared. Okay? All right, number 4. This is graph the data on the dot plot. So we're looking at our frequency table. Okay, it says responses, but really this is the frequency. So all the kids who had one sibling, there was 5 of them. Well, if we're doing a dot plot, we're going to put 5 dots above our 1. And remember, when we do our dot plot, we want to keep our dots really neat. We want to keep them the same size, and we want to keep them spaced out exactly the same distance, okay? So we've taken care of our 5. 2 siblings, there was 3 people. Again, remember, we want it to be straight across from the dots that we already have, spaced out the same, okay? We've got 3 siblings. There wasn't any children that had 3 siblings. We have 4 siblings. There was 2 children with 4 siblings. So again, we want to try to make our dots the same size and the same distance apart. And then we have 1 sibling for children with 5. Siblings of 5. And there's our dot plot.